Today we are going to be talking about a different way of solving systems of equations, and that is called substitution. So notes for today, again, there's only one page you actually need to write stuff down on, so it's going to be relatively short, but I'm going to introduce the problem a little bit similar to what we did yesterday. So starting with that same problem from yesterday, I believe our runners are not here. I don't remember who they all were. Was it, I think Pamela was our middle runner, right? Yeah, Pamela was the second runner. Who was our fast one? I know Todd was Brennan our fast runner? Yeah, it was Brennan. Okay, so two of our runners aren't here. That's all right. I guess that means that Pamela wins the race today. But anyway, so as you can see, we have three different lines in this system of equations, right? And yes, the lines are straight this time because I cheated and I drew them in with a computer program, not by myself. So as we can see, there's an intersection here. That's one of the solutions. So that's the solution to runner one and runner two, right? That's where the purple line and the green line intersect. The solution to these is 2, 20. So that's pretty easy to find by graphing. Another solution is right here. This is between runner 1 and runner 3. That one's also pretty easy. It's right on a point. It's at 3, 30. But then we get this one right here. This isn't on a point at all. It's not even on a half point. It's just kind of out here in space. You could approximate that, right? Like we could guess it's at about 3.7-ish, and it's at about 34, 33, somewhere in there. But we don't know for sure just looking at the graph. So there needs to be a different way for us to solve this. And the way that we're going to use to do that is called substitution. So the substitution method is another method of solving a system of equations, but it doesn't require the intersections to be at whole numbers. It involves substituting the value of a variable from one equation into the other. And substitution can be really complex, so it's important to follow the steps carefully. So we're going to get a lot of practice. I've broken this down into two sections. We're going to do kind of simple, like initial substitution problems that are all kind of the same format, so you're doing the same thing over and over again. And then we'll go into slightly more complicated ones next week. So if you want to write down this stuff, you can. You don't need to. It's not necessary. But I'll give you guys just a minute just in case. So again, at this point, if you're not comfortable doing the graphing method, so where we actually like draw the lines on a graph and then find where they intersect, that's something you definitely need to practice because that's going to be one of the more important things that you can do. And then moving on to substitution will be a little bit easier, I guess. Really quick, I'm going to go back and write these down. So 10x and 8x plus 4. Okay. So one thing I want you guys to notice, here's two of the equations from the last one. We know that the solution to these, because we graphed them, is 2, 20. One of the interesting things about this is if we check this point, we can see that it lies on both lines. So if we plug in 2 for x in the top one, we get 10 times 2. 10 times 2 is 20. So this point is on this line. And it's also going to be on this one. If we plug in 2 for x here, we get 8 times 2. That's 16 plus 4, which is 20 again. This wouldn't work for any other point. If we tried 3 for x, we'd have 3 times 10, which is 30. And then we have 3 times 8, which is 24, plus 4, which is 28. So there's no point that reaches or that is on both of these lines except for 220. So that's why it's a solution to the system of equations. Okay, so I'm going to move on. Like I said, if you haven't written this stuff down, it's not a big deal. We don't need this one. Here are the steps, though. This is really important to get down on your notes. So I'm just going to list out all of them, but I'm going to talk through them one at a time. So step 1 is to determine the variable you are going to substitute from equation 1 into equation 2. It is almost always going to be y equals mx plus b in some fashion, and you're going to substitute y. So the way we do this is actually a little bit easier than it sounds in this step. But when we get into really complex ones, you might have to do something a little bit different. If an equation is written in slope-intercept form, you can use the y variable from the equation. So like I said, that's the one that I was just talking about up there. Step 2 is to replace all instances of your chosen variable in equation 2 with the rest of equation 1. So what this means is, let's say I have y equals, we're going to use the ones I just did, y equals 10x and y equals 8x plus 4. So we already know that the solution to this is 2 comma 20. But what we want to do is we want to solve this using substitution now. So what we're going to do is we know that these y's have to be the same, right? So what we're going to do is we're actually going to replace what y is equal to in this equation for what we have for y here. So y is equal to 10x. Wherever we see y, this is equation 1. This is equation 2. So wherever we see y in equation 2, we can just plug in 10x. So we have 10x, because there's a y here, equals ax plus 4. And then we can just solve this for x. So hopefully you guys remember in the solving linear equations unit that we talked about, solving this one, we just do the minus 8x to move this over. So then we'd have 2x equals 4. You divide both sides by 2, and we get x equals 2. I'm going to go over this a couple different times, so you don't need to memorize it just from this example. It's just something I'm going to go over while we write. So that was step 3. We solved the equation for the remaining variable, so in this case, x. And now that we know what our x is, we can plug this back into either one of the equations. I'm going to use the top one because it's the easiest. Y equals 10 times 2 equals 20. So now we know what our y is. Y is 20. And that is what we get when we graph them as well. That was the solution we already had. So I'll give you a little bit longer to write this down, and then we're going to go over a couple of examples as a group. And then I'm going to have a couple that I want you guys to try. The homework for today, just since we've got a little bit, is just an IXL. And the reason for that is because the math space does both the simple and the complex substitutions together. So there's just going to be an IXL today, but then there will be a math space version of it next week. And it's, let me see, it's in the Google Classroom, but it is IXL. Should be posted. Oh, whoops, it's not posted in the Google Classroom yet. I will make sure. Oh, I scheduled it for tomorrow. My bad. I will fix that as soon as class is out. But it is IXL AA.8. So it'll be recommended in IXL. You guys should be able to see it. Does anybody need more time to write down these steps?
Yes, give me like a minute.
Okay, no problem.
Thank you.
And then when I'm going through these examples, I'm going to go through them step by step, so one step at a time, so that way you guys can follow along with the steps that you have written down. So we're going to see exactly how we use it. And I will tell you for the simple substitution problems, step 1, you're always going to have them written in, you're always going to have them written in slope-intercept form. So step 1 will be pretty easy for the most part. Okay. 30 more seconds be enough?
Yes.
Okay. Okay, so let's look at an example problem. So we want to follow the following system of equations using substitution. This will be problem A, this will be problem B. I'm not going to make you guys do these on your own yet. We're going to walk through them together as a group. So step one is to determine the variable we're going to substitute. In this case, since both of our equations are y equals and y equals, the easiest one to substitute is going to be y. So we're going to pick y. So what we're going to do, whoops, this is equation 1, this is equation 2. You don't actually have to label them, but it can be helpful. So this is equation 1. We're going to take equation 1, the y value of equation 1, which is 3x plus 2, and put in 3x plus 2 wherever we see y in equation 2. So that's step 2. So in this case, we have 3x plus 2 for y. Y is right at the start, so we have 3x plus 2. I'm going to keep it in parentheses just so we can see that it's replacing y, equals x minus 3. So now we have this linear equation, 3x plus 2 equals x minus 3. And we just want to solve this for x. So this is a little bit of a throwback to stuff we were doing before the break. So if you're a little rusty on this part, that's okay. We're going to get lots of practice on it. But we want to solve this for x. So the first thing we want to do is get our x's on the same side. I'm going to subtract x. Subtract x from here. X minus x is 0. We still have the minus 3. And on this side, we have 3x minus x, which is 2x. And then we still have our plus 2. So now we have 2x plus 2 equals negative 3. I solved the 0 minus 3 just to skip a step. So 2x plus 2 minus 3. Now we want to subtract 2 from both sides. 2x plus 2 minus 2, that's just 2x. There's a 0 here if we want to think about that, but we can ignore it. And then we have negative 3 minus 2, which is negative 5. So now 2x equals negative 5. This is still step 3. Step 3 is the longest step, by the way. Then we're going to divide both sides by 2. So x equals negative 5 over 2. Now, the last step, step 4, is to plug in our x value into either one of these equations. I personally think that the second equation is a little easier. It's just x minus 3, so I'm going to plug it in there. So we have y equals, and then instead of x, we're going to put in negative 5 over 2 minus 3. Negative 5 over 2 minus 3, we can think of 3 as 6 over 2. So we have negative 5 over 2 minus 6 over 2. This is equal to negative 11 over 2. So the answer to our system of equations, our x value is negative 5 over 2. Our y value is negative 11 over 2. And that is our point. Okay, so that was probably pretty confusing. So we're going to go through another one. So step 1, again, is to identify the variable I'm going to substitute. Like I said, all the problems we're doing right now are in slope-intercept form, so we're just going to choose the y. Again, we'll take equation 1 and equation 2. I'm going to put this in parentheses because this is what I'm replacing y with. So we have 2x plus 4 wherever we see y over here. Y is, again, the start, so we're just going to do 2x plus 4 equals, and then we have 3x minus 1. So now we're left with this linear equation. We've done step 1 and 2. So now we just need to do step 3. We need to solve for x. Again, to do this, we're going to get our x's on the same side. This will give us 0 plus 4 equals 3x minus 2x is just x minus 1. So we have 4 equals x minus 1. I'm going to add 1 to both sides. This gives us just x, and this gives us 5. So x equals 5. A little bit easier this time, a little bit of a nicer number. And then we just need to do step 4. So we're going to plug this back in to either one of our equations. This time I'll use equation 1. So we have y equals 2. And then since x is equal to 5, we're going to replace the x with a 5 plus 4. So y equals 10 plus 4. Y equals 14. Actually, that's not the answer. Hold on. Sorry, shouldn't have boxed that. So now we know our x, we know our y, we write them as a point. One last step, 5, comma, 14. So this is our actual answer. Okay, so I'm assuming there are a lot of questions about this. So we're going to try working through them as a group now. So our new equations, first one, let's just look at this one. So we have equation 1 and equation 2. So what is my first step? Anybody? You all wrote this down, so you can just read off what it says. Oh no, I think I scared them. All right, I'm going to pick on somebody I know who has a microphone. So Dane, what is step 1?
The
Oh, Pamela got it in chat. Pamela, can you put that in everybody chat so everybody can see it? Yep. So put equation 1 where y is on equation 2. So we're going to take the equation 1, this stuff, and replace it with the y here. So we have 2x plus 2 equals 4x minus 6. So that's our first step. 2x plus 2 equals 4x minus 6. All right. Now, what's the next step to solving this for x? What's the first thing you guys want to do? Anybody? Usually Todd is here to just blurt out answers right off the bat, whether they're right or not. It's okay if you guys get it wrong. That's the point of doing the whole thing as a group. Okay, add 6 to both sides. So Barb's idea was to add 6 to both sides. That's a good first step. And add 6 and add 6. So when we do that, now we have 2x plus 2 plus 6 is plus 8 equals 4x. And then 6 minus 6 equals 0. So 4x was 0. So now we have 2x plus 8 equals 4x. Anybody have any other ideas to solving this? Dividing both sides by 4, you could, but it's going to give you a half x on one side. So we don't want to do that just yet. There's one thing we want to do first. What do we always want to have on the same side? We're not going to add 4x to both sides because that will make this side 8x. We could subtract 4x from both sides, But in this case, it's actually going to be easier to subtract 2x. So the reason is we want to get our x's on the same side. So if we subtract 2x from both sides, you get 0, because 2x minus 2x is 0, plus 8 equals 4x minus 2x is 2x. So now we have 2x equals 8. And now what's the last step? Oh, come on. I know you guys know how to do this one. There we go. Thank you, Dane. Yes, divide both sides up by 2. So we do that and we get x equals 4. Okay. Now that we know what our x value is, we got to plug it into either one of our two equations. So do you guys want to do equation 1 or equation 2? Equation 1. All right, good call. I like that one better too. So if we plug that into equation 1, we have y equals 2 times 4 plus 2. 2 times 4 is what? Yep, 8. So now we have 8 plus 2, and 8 plus 2 is 10. Good. That equals 10. So x equals 4, y equals 10. That means our answer is the point 4, comma 10. Okay, so I'm getting the sense that this is a little bit tough for people right now. That is okay. We're still going to go over this last one before we take off today. But I still want you guys to try the IXL to get a little bit of practice in. We will work on this more on Monday as well to get extra practice. So don't worry about it if you can't figure it out right away. So I will extend the due date for the IXL assignment for tonight. But let's go ahead and try this last one together. So again, what is my first step? What's the first thing that we did in this equation? Yep, we're going to set our equations equal to each other again. So this time, we're going to take this negative 2x plus 4 and set it equal to our 1/2 x minus 1. So negative 2x plus 4 equals 1/2 x minus 1. Okay. Any ideas? What's my next step? We could add 1 both sides. That works. This gives us negative 2x plus 5 and 1/2 x plus 0. So now we have negative 2x plus 5 equals 1/2 x. All right, what's next? What do we want to get on the same side? Pamela, yes, that works, and you can solve it that way. But I want somebody else to answer. It's not just you every time. And Barb, that is correct. We do want our x's on both sides. So can anybody think of a good way to get our x's on the same side? How about I be more specific? How do we move this negative 2x to the other side? Yep, we're going to add 2x. I'm going to assume you missed the x there. So if we add 2x to both sides, we get this is 0 plus 5 equals, and then we have 2 and 1/2 x. We could also write this as 5 over 2x, whichever way you want to do it. And then our last step, we have 5 equals, we'll do 5/2 x. What's our last step? Or I guess we could think of it as 2 steps either way. Because this is a fraction, this might be a little bit more confusing. So Yeah, you divide by 2.5 on both sides. But since it's a fraction, we're just going to multiply by the reciprocal. It'll be a little bit easier. And you'll get the same thing. So 5's cancel, 2's cancel. And we're left with 2/5 times 5 is 2. So x equals 2. You could have also done 5 divided by 2.5. That's the same thing. 5 divided by 2.5 is also 2. So we got 2 for our x. Now, which one do you guys want to put that in for? Equation 1 or equation 2? Equation 2. All right. So we have y equals 1/2 times 2 minus 1. What is 1/2 times 2? Yep, 1. And 1 minus 1, everybody should know that one. Y equals 0. Good. So we have x equals 2. We have y equals 0. Our point is 2, 0. Okay. So I'm going to stop recording.